All right. Well, welcome back, guys. So a couple things to point out. Notice we're calling this unit 8b, and that is simply because it's really just a continuation of our unit on reactions. All right. And we're going to focus in on what are called net ionic equations. And what those are is understanding the fact that not everything is involved with an actual reaction, right? So we've been doing what are called molecular equations. Molecular equations show all the compounds involved. That's what we've been doing all along. Net ionic equations focus only on the ions actually participating in the reaction itself. Okay? And so what we're going to learn to do is recognize spectator ions and eliminate them when pertinent. All right. So step one, we're going to start with a balanced molecular equation, including the notation for solid, aqueous, etc. So all that stuff we learned on how to write the equation, note whether there's a reaction or not, identify aqueous, solid, etc. All that is our starting point for our net ionic equation. So this is kind of a culmination of everything we've learned so far regarding reactions. All right. So if I have aqueous silver nitrate and aqueous calcium chloride as my reactants, all right, how would I go about writing that molecular equation, right? So silver is +1, nitrate's -1, calcium's +2, chlorine's -1. And so when I write my associated molecular equation, right, I get my silver nitrate and calcium chloride. I predict my products as silver chloride and calcium nitrate, right? I label aqueous, etc. A precipitate does form, so there is a reaction, and I go back and balance. All right. So that should be nothing new to you guys. This is something that you should have been working toward mastery of all along. Okay. So our net ionic equations start with what we're going to call a molecular equation. All right, that is balanced in everything. So that's step one. We just write out our balanced molecular equation like we've been doing all along. And yes, these little symbols that I was nitpicky on in your last test are important. All right. The next step, okay, is we're going to write all the aqueous compounds in their ionic form. Right. And I kind of showed you guys how to do this when we did our acid base unit, but let's illustrate what we mean. So we're going to write what's called the total ionic equation. So everything that has an AQ, right, is going to be split apart into the individual ions. All right. So in this case, I'm going to split the silver from the nitrate, the calcium from the chloride, right? This is solid, so it stays as it is. And then I'm going to split the calcium and the nitrate. Okay. So watch what I do here. We know silver is a +1. So my total ionic equation looks like this: 2Ag plus, and that 2, remember, is distributed to both parts of that compound, 2NO3 minus. So when I split these up, I have to distribute that 2 out accordingly. All right. Now, my other ions on my reactant side are calcium and chlorine. So plus Ca2 plus. And now notice that subscript 2 applies only to the chlorine ion. All right. And so what I'm going to do is I'm going to keep 1 calcium, so no coefficient there, but that subscript is going to become a coefficient, 2Cl minus. Okay. Now, these are my ions in solution: silver ions, nitrate ions, calcium ions, and chlorine ions. All right. Now, the other thing to note is the little subscripts that are attached to my polyatomic ions. I leave those where they are. All right. That can be a little confusing, I get at times, but just like that rule we learned way back when we learned how to use polyatomic ions, the subscripts that are there, we just leave them where they are. We don't change them. All right. So it's the added subscripts that become coefficients. Okay. So my right-hand side now is going to be 2Ag plus 2Cl minus. Again, oh, whoops, I just screwed that up. Holy cow. Sorry, I almost made the mistake that many of you guys are going to make. That's solid. I do not change that. That's AgCl. Solid, like that. Okay? So again, easy to do because I almost did it. Bad science teacher. Serendipitous though, so I can demonstrate how we make those mistakes. right? If it's a solid, we do not write it in the ions, all right? And then plus, this is aqueous, so Ca2 plus, and I have two nitrates, 2NO3 minus. Okay? So that is my total ionic equation. So I take anything with the AQ, not the ones that say solid or gas or liquid, right? And I separate the aqueous compounds into their individual ions. Added subscripts become coefficients. Coefficients distribute to everything in that compound. All right? So that's step 2. Now, what I'm going to do next is I'm going to look at both sides of my total ionic equation. And I'm going to eliminate spectator ions. Okay? Spectator ions are the ions that look the same on both sides. All right? So, now notice silver on the left side is 2Ag+. On the right side, it's part of this solid molecule. So it does not look the same on both sides. Nitrate, on the other hand, says 2NO3 minus on this side, and it remains in solution there. So I'm going to cross nitrate off. That means that nitrate isn't actually part of this reaction. It's what we call a spectator ion. So it stays in solution on both sides. Okay? Calcium, likewise, stays as an ion on both sides. So we're going to cross that off. Chlorine is an ion on the left side, part of a precipitate on the right, so it stays. So again, I'm looking for ions that stay aqueous on both sides and canceling them out. Anything that began as an ion but became part of a precipitate stays. Okay? So I'm eliminating those. So that's total ionic equation. The final step is I just write what's left over. So I'm getting rid of those spectator ions. So the way this would be written is 2Ag plus 2Cl minus yields 2AgCl. Because in reality, the nitrate and the calcium are not part of that reaction. They are in solution here and on the right-hand side. Okay, and that's how we do net ionic equations. When you walk in the door tomorrow, there'll be a quick little lecture quiz. This is a short one. All right, peace.